12 in healthcare finance. This case study is about Pensacola Surgery Center, located in Florida, investor-owned chain of ambulatory surgery centers with 6 different locations. Some of the situations: the company has $100,000 in cash, but has a target value of $50,000 for cash. Gary is looking for investments for the excess $50,000. He is also looking into purchasing a new billing system that will have a future value of $200,000. Finally, he's also considering leasing out some extra space for 5 years. Renovations would cost $40,000, but would include uneven cash flows over the next 5 years.
Okay, so for problem number 1, Gary has a couple different options to consider for investing $50,000 in excess cash. So for the first part A, that option is a CD, or certificate of deposit, that pays 10%, and the period is just going to be 1 year. So if we come over here to Excel, you can just see the function we use in order to calculate this. You use the future value function, and right here you're going to put the interest rate, which is 10%, and we put that as a decimal point 1. And then right after that, you're going to put the number of periods, and this is going to be in there for 1 year. And then the initial investment, which is going to be a negative number because it is an outflow. You're investing that $50,000. And then putting that into Excel, you come up with $55,000. So that's how much that investment is worth after 1 year. Part B is basically the same thing. You're just changing a couple of the numbers. So instead of 10%, this is going to pay 5% for 1 year. And you come up with $52,500. And then the last part of this problem, you're just going to change the interest rate to 15%. And after 1 year, that initial $50,000 investment is going to be worth $57,500. Now on to question 2, which is very similar to question 1. We're just going to rework it. The only difference is the time period. Instead of 1 year is going to be 5 years. So now over in Excel, you're going to be using the same function, the future value. You're still going to be using the 10% on the first part. The only thing that's changed, like I mentioned, is the number of periods will be 5 because we're leaving the money in there for 5 years now. So after 5 years at 10%, that investment is going to be worth $80,525.50. After 5 years at an interest rate of 5%, it'll be worth $63,814.08. And then as you can see, if it's gaining 15% after 5 years, that investment will have more than doubled to $100,567.86.
Okay, so moving on to question 3. Okay, so they want to look at a goal of having $200,000 available in 5 years to get a new patient billing system. So what we need to know is what amount of money do we have to invest in a CD that pays 10% that we can get $200,000 when we're done with that CD. So going over to Excel, what we did is we used the present value function, and we put in 10% here, and then we 5 years here, and then they want to know how much money. So it's going to be, we want $200,000. So it's going to take $124,184.26 in order to get that amount of money in 5 years. The second part of that one is what annual interest rate is needed to produce $200,000 after 5 years if only $100,000 is invested. So we're looking at only investing $100,000 instead of $124,000. Going over to that, So what we did is we did a rate function, and we're doing 5 years here. Our amount of $100,000 invested there, and then what we want to get out of it, so $200,000. So that came out to 14.87% interest rate.
On to question 4. The first part of question 4 asks us it says, now consider a second alternative for accumulating funds to buy the new billing system. In lieu of a lump sum investment, assume that 5 annual payments of $32,000 are made at the end of each year. So the first part A, asks us what type of annuity is this? And the answer is ordinary, because the payments are made at the end of each year. So that's the reason why it'd be ordinary, because ordinary annuities just come at the end of each year rather than the beginning. So part B now asks us, what is the present value of this annuity if the opportunity cost rate is 10% annually? So if we go over to Excel, we'll actually take a look at what we have here. So due to the fact that there's cash flows coming in, we're going to be using the net present value to see what is the present value of the annuity. So as you can see, the opportunity cost rate, we inputted for rate, which is 10%. And then the values, since it's a constant flow of $32,000 coming in, we actually just put that in 5 times for each year. So you can see for each value 1, value 2, all the way up to 5, it's going to be the same $32,000. So the answer to B is $121,305.18. Now it asks what happens if this was to be compounded semi-annually. Now the issue that we face with this problem, we found to be a little bit more difficult, was that since it's compounding semi-annually, the interest rate isn't going to be the same. It actually changes, and that's actually when we use what's called the EAR formula that's found in your book. And the nice thing is we actually were able to find a formula in Excel that helps you find that interest rate much quicker. So I'll actually show you right here in Excel next to it. The formula is called, or I guess the function is called effect. And it just asks you what the rate is. So we know that it's 10%. And then the number of periods in a year it asks. So we know semi-annually, so that's going to be 2 periods. And then it comes up, we'll change that as a percentage, and you can see that it is 10.25%. So that will be the interest rate that you use within the net present value with the second part of B. Everything else will be the same as far as the payments. You still have those 5 payments over 5 years. But as you can see, the present value, the net present value is going to be $120,534.40. Let's move on to C. C asks us, what is the future value of this annuity if the payments are invested in an account that pays 10% interest annually? So let's go over here. We're using the future value because that's what it's asking for. We have our 10% rate, interest rate annually, as it says in the problem. It's over 5 years. The payments are negative $32,000, and there is no present value because we don't have an initial starting amount. So as you can see, the answer is $195,363.20. And it asks the same question as far as what happens if we are to do, if the 10% is compounded semi-annually. So if we come over here and look at the function, you can see that the percentage and the number of periods are different. And the reason why that is because, I'll actually show you what we did. We had the 10% interest rate, but we divided that by 2 due to the fact that it's compounding semi-annually, so 2 times, and then we're timesing the number of periods by 2.
So this allows for the, I guess, to do the semi-annually compounding within this formula. This will give it the correct answer. As you can see, it's the future value is going to be $201,246.28. Now let's move on to D. D asks us, what is the annual interest rate? What annual interest rate is required to accumulate the $200,000 needed to make the purchase, assuming a $32,000 annual payment? So you see that it's asking about interest rates, so that gives us a pretty clear idea. We'll be using the rate function. It's over 5 years. That's the number of periods. Negative $32,000 for the payments because we're paying that. We do not have a present value, or it's 0 because there's not an initial lump sum investment. And we're looking for a future value of $200,000. So our interest rate is going to be, the one that we need is 11%, 11.18% to be precise. And the last part of question 4 asks us, what size annual payment would be needed to accumulate $200,000 under annual compounding at 10% interest rate? So as the beginning of the problem indicates, we need to find out what the payment is. So we'll be using that payment function. So for E here, we're using payment. The rate, like it asks, 10%. Number of periods, 5 years. There's no initial investments. We have 0 for our present value, but we do want $200,000 in the end for our future value. So the payments would be negative $32,759, I guess, yeah, $50. The reason why it's negative is because those are the payments that you're making into the investment. So you're losing the money in the sense that you have to give it up to the investment. Now we're going to move on to question 6. It says, now consider the uneven cash flow streams stemming from the lease agreement given in this case. What is the present value of the annual lease cash flows if the opportunity cost rate is 10% annually? If we come over to Excel, we look at 6A. So we have that 10% opportunity cost rate inputted for the net present value. Because we have this uneven cash flow, it's not like the other problem where we saw $32,000 over each year. Each cash flow was different. So you can see for year 1, we had $12,000, year 2, $14,000, year 3, $2,000, year 4, $16,000, and year 5, $20,000. So when they're uneven, you have to make sure to enter each value for the end of the year into net present value. We hit enter, it accumulates quickly. We end up showing $47,000 or $47,328.61. And the last part of question C, or sorry, question 6 for C, it asks us, does the office renovation and subsequent lease agreement appear to be a good investment for the company? So the answer is yes, but let's go into why it's yes. So our initial investment is $40,000. And for what we can see for the answer for A is that the present value of the investment is $47,000. So it's $7,000 more. So what I guess the way we calculate this is we say this investment is worth that $47,328 versus if I just had that money now, it's only worth $40,000. So obviously the investment, since it's almost a little over $7,000 more, is going to be a good investment because it's worth more.
Okay, moving on to question 7. It says, now assume that it is 5 years later and the company is unable to accumulate the $200,000 needed to make the software purchase. Instead, it is forced to borrow the funds at a 10% rate. The loan calls for repayment of equal annual installments over a 4-year period with the first payment due at the end of year 1. What amount of interest and principal will be paid at the end of each year of the loan? Okay, so the answer, so you'll get a payment of $63,094.16. So if we come over here to Excel, we just made a short little amortization table So your zero, or the first year balance of the loan is $200,000. So then we just figured out the payment of that over the 4 years. We use the payment function, so at 10% interest for 4 years of $200,000. And then we just break it up. You times the payment. You take the payment, and it'll come out to be $20,000 in interest. And then the principal for that first year, you're paying $43,094.16. And then you get the balance at the end of the spreadsheet. And you just, the spreadsheet just flows like that from the payment down with the interest and principal to balance until in the 4th year when it zeroes out. And then over here we have it broken down as well. And that's everything.
If you have any questions, feel free to post onto the on iLearn. We'll make sure to answer your questions or explain anything that wasn't unclear within the video. Good luck with your case study.